And I'm giving the floor for Roohai Dalal from Princeton University, and she will be speaking on national security insurance in relation to dark and quiet sky advocacy.
Hey, so hi everyone, my name is Roohai. I'm a final year grad student at Princeton where I study cosmology using wide field galaxy surveys. So I'm one of the many people whose research is impacted by satellite constellations, but I'm also very involved in the security studies and science and global security programs. And so in this talk, I'm going to try to bring the two together and talk about particularly US national security interests in relation to dark and quiet skies, and sort of propose a way forward in which we can collaborate with the Department of Defense on dark and quiet skies issues. So again, this is going to be primarily US focused because that's the area in which I have the most knowledge, but I'd be interested in hearing from everyone here how this might apply to other countries as well. So I'm going to try to answer the questions of why the Department of Defense should care about dark and quiet skies, and why we as dark and quiet skies advocates should care about what the Department of Defense is doing, and then finally end with a potential path forward. So again, the first question I'll try to answer is why everyone in this room should care about Department of Defense plans. And I'll start by outlining sort of what the current state of military uses of outer space is. So there's a lot of information on the slide, but the primary takeaway here is that currently the Department of Defense and the Space Force have mostly been relying on satellite systems in geostationary orbit. And for the most part, these have been systems with a small number of satellites that are used for communications, early warning, and missile tracking, as well as some degree of theater and intelligence missions. And because these systems have such a small number of satellites, and each of these satellites is quite large, expensive to produce and launch, these systems are pretty vulnerable to attack. And so just a year ago, it was announced that the Space Force is going to stop deploying these systems to geostationary orbit. So the current sort of set of satellites that's being launched, the next generation OPIR, is going to be the final sort of satellite system planned for geostationary orbit. And instead, the plan is to move to low Earth orbit. So this announcement was made by the Space Development Agency. And the Space Development Agency was set up in 2019 to disrupt military satellite acquisition by putting a new set of minimum viable capabilities on orbit every 2 years. And in doing so, they're actually trying to emulate the smartphone industry's approach to upgrades, consistent upgrades. And so the main plan that the Space Development Agency has at the moment is to build a layered network of satellites that they're calling the Proliferated Warfighter Space Architecture, or PWSA. And this is going to consist of 2 main layers of satellites: the transport layer, which is primarily communication satellites with optical crosslinks, and then the tracking layer, which will be used for missile detection and early warning using infrared sensors. And so they're planning to have 1,000 of these spacecraft on orbit by 2026. And the goal of having so many satellites is for the bullet to cost more than the satellite. So if someone were to launch an attack against these satellites, it would be more expensive than the cost of quickly replacing that satellite. And I think what's unique about this system is that the SDA is ordering satellites from multiple vendors. So that includes SpaceX, York Space Systems, Northrop Grumman, Lockheed Martin, L3Harris, Raytheon, and Ball Aerospace at the moment, but could include more vendors soon. And the key thing here is that they're requiring that the satellites be interoperable. So they have to be able to communicate with each other, which means there's a standard set of guidelines for producing these satellites. And I think that this is something that we can leverage, which I'll get to later on. So the current status of this proliferated warfighter space architecture is that they're currently deploying a demonstration constellation, which is referred to as Tranche 0. So 23 of the planned 28 satellites in this smaller demonstration constellation have been launched already. Those consist of 20 transport layer satellites and 8 tracking layer satellites. So 20 for communications and 8 for early warning. But pretty soon they're going to be fielding the first operational layer of the PWSA, and that's Tranche 1, which will have about 180 satellites total. And those will include transport and tracking layer satellites, as well as 12 tactical demonstration satellites, which are intended to demonstrate and experiment with tactical satellite communication and integrated broadcast service capabilities from low Earth orbit. And these will all be at about 1,000 kilometers in altitude. So in addition to this proliferated warfighter space architecture, the SDA is also working on a tactically responsive space effort. So this is basically rapid launch capabilities. They want to be able to rapidly launch satellites to counter any potential adversary offensives. And so this was most recently demonstrated just a few weeks ago when the Firefly Aerospace launched one of the US Space Force's space domain awareness missions within 27 hours of receiving orders. So that meant that they encapsulated the payload, transported it to the launch pad, made it to Alpha, fueled it, and then launched it, all within 27 hours. And so I think we can expect an increased number of launches as they continue to build this rapid launch capability. And so that could lead to more unpredicted light pollution as these satellites, both from the launches themselves and as these satellites are raised into their final orbits. I also think that this rapid turnaround could potentially stifle regulatory efforts because these would sort of be a hindrance to the capability to quickly launch satellites. And so I'm going to turn this to the other side, which is why the Department of Defense should care about dark and quiet skies issues. And there are a number of issues here that I think have been discussed in previous reports like Dark and Quiet Skies or SATCON, or discussed at this conference that I'm not going to touch on here. So that includes the general concern that as low Earth orbit becomes more crowded, there's more potential to generate debris that could hit these satellites. Questions about planetary protection because we're trying to observe solar system objects along the horizon. And then I think the laser clearinghouse that we talked about a few days ago is also kind of closely related, but I'm not going to touch on that here. Instead, bring up 2 other issues that I haven't seen discussed as much. The first is radio interference, because this also affects the Space Force satellites. So as demand for the spectrum grows, overcrowding of radio frequencies could lead to degradation of, or even denial of security-oriented capabilities if the military is not able to get access to the radio frequencies they need as a result of that increased demand. And I think this could be exacerbated by the unintended radio signals that we've heard a lot about over the past few weeks. And so I would suggest that national security could be bolstered by stricter regulation on spectrum allocation and minimizing leakage. And I think that's an argument that we should be making. The other idea here is that perhaps satellites could interfere with theater intelligence missions. So the Space Force still has satellites in geosynchronous orbit that are providing technical intelligence. So that includes theater missions and battle space awareness. So they're looking for infrared signals that don't have as strong a signal to noise as a missile launch, for example. And it's possible that they could have the same problem looking into Earth that we have looking out, which is that the thermal emission from a kind of crowded shell of satellites in low Earth orbit could start to interfere with this intelligence gathering. Unfortunately, we don't know the sensitivity of the sensors on these satellites. That's, I think, classified information. I haven't been able to find it. And so it's a little difficult to evaluate this, but maybe it's a conversation that we could start. And so I'll just end by describing a potential collaborative path forward. And that's the idea of norm creation through these Space Development Agency contracts. So just a few weeks ago at the AMOS conference, the Space Force Chief of Space Operations rejected their draft commercial space strategy, saying that it really needed to move from aspirational to actionable. So they were really looking for concrete sort of ideas about how they would interact with the commercial space industry. And I think generally the DoD should be interested in reducing their reliance on commercial space capabilities. I think we've seen that these kind of enable just a single person to have a lot of control over how war fighting goes. And so instead, I think the DoD will be expanding contracts with private industry, like through the SDA PWSA satellites. And they are setting clear requirements in these contracts. So a few days ago, I think SpaceX won a contract from the Space Force for its new Starshield constellation, which is basically the same capabilities as Starlink, but they are setting certain particular requirements on those satellites. Those have not been made public, but I think the idea that the SDA is kind of setting these guidelines in their contracts means that we could leverage them to encourage night sky protections and light pollution mitigation measures to be a part of these contracts. And in particular, the interoperability requirement of the transport layer that's being built for the SDA that is across so many different satellite or different commercial space industry operators means that they could, by including these light pollution mitigation measures as part of those contracts, they could build a set of norms to reduce the reflectivity of these satellites. And maybe that could eventually become a regulatory regime. But I think especially the fact that they are already working with a number of different operators, if we can get some language about light pollution mitigation into that, I think that would be a really strong path forward. So with that, I'll just finish and take any questions.
Thank you very much, Rui, for such an interesting presentation. And thank you for keeping the time, by the way, we can catch up. We have a room for one question. We also have a question from online question. Yeah.
Lisa Ruth Rand, Caltech. Roohai, thank you so much for this presentation. I'm curious because historically the DoD has been able to gain exemptions for a lot of things, particularly historically orbital debris, right? You can have standards, but if it's defense crucial, there's an exemption. So I wondered if you've encountered any of this or how you are incorporating this into your analysis, this kind of penchant for exemptions, the DoD. Thank you.
Yeah, I think this is where it will be important to convince the DoD that they actually should care about these mitigation measures. I think, yes, it's very possible that they could get exemptions. I think they will also not care so much about their satellites not being very reflective or bright in the sky because they'll have such a proliferated LEO environment that it's okay if their satellites are seen and one is taken down. So I think this is where we really need to convince them that they should care, and that's the first case that we need to make.
Thank you very much. I think if it's possible, you can answer the online question, Marcel. Thank you very much.